Okay, we're starting 7-3. Just because I want to go back through this again, we're going to fill this little box out. So don't look at your sheet. And you guys help me fill this out, all right? Parallelogram, I always draw mine this direction. I don't know why. You need to be quiet. Here's a parallelogram. Things about the parallelogram. We have 5 different things that make it unique about a parallelogram. 2 things have to do with the sides. What do we know about the sides of a parallelogram? Don't cheat.
Opposite sides of parallel.
Opposite sides are parallel, okay? So, Hallie, if you're filling the sheet in, fill them in. Opposite sides are parallel, okay? What little markings do I do so I know that he's parallel? The little arrows, okay? If they're not parallel, he's not a parallelogram, right? Opposite ones have to be exactly parallel. Okay, now, let's think about this. If they gave me coordinates, hold on. Shh, listen. If they gave me coordinates, like let's say this is 5, 5, and let's say this is 4, 0, and let's say this is 0, 0, and let's say this is, I don't know, 1, 5, right? Let's say that they gave me coordinates. Don't write this down. Let's say they gave me coordinates, and they say, is that a parallelogram? How could I prove that by showing that the opposite sides are parallel?
Find the slope.
Find the slope. Okay, so let's look at slope from here to here. How much is it going up and how much is it going over?
Up 5.
It's going up 5 and over 1, right? Up 5 over 1. Okay, is this one also going up 5 and over 1? Yeah, okay. Now let's talk about this guy. What's the slope of this one right here? Up 0 over 4. So it has a slope of 0. What about this one? 0 over 4. Okay, so in this section, we're going to be proving that. They're going to be giving me coordinates and say, show that it's a parallelogram. We just found the slope of all 4 sides, and they were correct. Okay?
Opposite sides congruent.
Okay, the next one. Blah, 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 blah. That was using slope. We proved that. Okay, so I'm going to go to the next one. Let's say we want the opposite sides congruent. How do I talk about congruence? Okay, this guy and this guy have to be the same length, and this guy have to be the same length. Okay, how do I talk about length? What formula does that use? The distance formula. So I want to find the distance formula. I don't really have to do distance formula for this top one. I can just count. How much is that? 4. And this one is also 4. And then I would have to do the distance formula here, right? It's up 5 over 1. That would be the square root of
4.
26. Good math. Up 5 and over 1, that would be the square root of 26, right? So I'm looking at the distances now instead of the slopes, right? If I'm proving that the opposite sides are parallel, okay? That checks out, so this is a parallelogram. All right, moving on. Let's talk about angles now, okay? In order for this to be a parallelogram, what has to be true about the angles? Opposite angles are congruent, which means this guy is the same as that one, and this guy is the same as this one, right? Yes?
Oh, we did.
Yeah, okay, we'll skip that. What? What do you mean?
Like opposite sides.
For the fourth thing or what?
Yeah.
Oh.
Like,
What's the fourth guy? That's hard to remember. Hey, if you guys aren't going to listen, you can go. Shush. You want to?
No, I'm kidding. I'm listening.
There's your invitation.
Okay.
All right. The fourth one I had you put a star by, and it has to do with the angles. Okay, what about the angles? Yeah, consecutive. What does consecutive ones mean? The ones that are right next to each other. So these two would add up to be how much?
1980.
1980. Consecutive equal 180. They add up to be 180. Consecutive ones are supplementary. Okay, that would be like the same with the bottom two. The bottom two are consecutive. They're right next to each other. So those would add up to be 180 all the way around. Okay, and then what's true about the diagonals? Diagonals are these guys. Are they the same length?
no.
Like this one's longer than this one, right? You can see that, hopefully. I don't know. But they do bisect each other. So this is the same length as that, and this one's the same length as that. What? Now, let's say we're talking about diagonals real quick. Let's say we're talking about diagonals, and let's say we're trying to prove that the diagonals bisect each other. If they bisect each other, this is called the what? The midpoint. Okay, real quick. From 1, 5 to 4, 0, can you find the midpoint? How do you find the midpoint? Okay, shh. There is a lot of extra talking going on.
Find the distance divided by 2.
No, I don't want to do that. How do you find the middle of something? Finding the midpoint is like finding the average. Okay, let's average 1 and 5 and 4 and 0. What's the average of 1 and 4? You add them together.
2.
Divide by 2.
2.5.
2.5. This is 2.5 comma something, okay? 5 and 0. What's the average of 5 and 0? 2.5. So according to this, the middle from here to here is 2.5 comma 2.5. Let's see if from here to here is also 2.5, 2.5. So what's the average of 0 and 5? 2.5. What's the average of 0 and 5? Also 2.5. So they have the same middle point, which means that the diagonals bisect each other. Does that make sense? They have the same middle point. Other, and I still spelled each other with 2 letters, but anyway, okay? All right, so there's that. Let's go to the notes. To the notes. To the notes. We are on, let's go to example 1. Identify, determine whether the quadrilateral is a parallelogram, justify your answer. Is that a parallelogram?
Yes.
Yes, how's come? Opposite sides are?
Parallel and
Congruent.
I don't know that they're parallel. I only know that the opposite sides are congruent. Okay, now, which theorem up here says that the opposite sides are congruent?
510.
What? Opposite sides are congruent.
7.9.
7.9.
If both pairs of opposite sides of a quadrilateral are congruent, they say the same thing, doesn't it?
No, angles is the 7.
Oh, yeah, this is angles, this is sides, so it is 7/9. Okay, so we would put yes because of theorem 7/9. Okay? All right, example 2. Use parallelograms to find the values. Use parallelograms to find the values. The top of the eraser appears to be a parallelogram. Find x and y. Okay, this angle is 7x. This angle is 4y plus 4. This angle is 56. This angle is that. What do we know? The opposite ones are equal, so I can say 56 equals 7x. These two things are the same.
X equals 8.
X equals 8. Okay? Now, these two are also going to be the same. Let's solve that. 4y plus 4 equals 5y minus 26. Add the 26 over, that's 30. Subtract the 4y. So what do we got? Y equals 30. Do we have to find anything else? Find the values of x and y. There we go. That's it. Like this is kind of the same as what we've been doing, right? Okay. Moving on. Example 3. Okay. All right. This is where it gets a little confusing. You got to listen to this. This is where it gets a little confusing. Because we haven't done this before.
Actually, that is not a parallelogram.
Okay. Shush. Okay. They say determine whether it's a parallelogram. Justify by using the midpoint formula. Okay. So what we're doing here is we're checking the diagonals, right? Okay, let's put the coordinates down of each one of these. J is at -2, -1, right? Okay, what about H? 4, -2. G is at 4, +2. Okay, F is at -2, 4. Okay, so here's the deal. They say use the midpoints to find whether this is a parallelogram or not. It doesn't look like a parallelogram. I'm guessing we're going to say no, but we have to justify our answers. So they want us to do the midpoint. Which two are you going to do the midpoint of?
4 and 2.
Opposite ones, right? Because I want to look at the diagonals. So I'm going to do the midpoint there. Finding the midpoint is like finding the average. So I'm going to average those together. Okay. If I average 4 and -2, you're adding them. 4 plus a -2 is how much? No. What's 4 plus a -2? 2. And 2 divided by 2 is? 1. So we have 1 comma something, right? Okay. What are you talking about?
2 divided by 2.
Okay. Okay. Here we go. We're looking at 2. No. 2 divided by 2.
You are.
We're adding 4 plus a -2 divided by 2, right? And then we do 2 plus a -1 divided by 2. This is the x coordinates, and these are the y coordinates. Yeah? Okay. 4 plus a -2 divided by 2 is 1. 2 plus a negative 1 is 1 divided by 2, so that's a half. So I should move this guy down just a slightly tick. Okay, he is the point 1 comma 1 half. Yeah? Okay, now we want to test the other diagonal and see if he is also the same. So I'm going to do this, negative 2 and 4. If I take negative 2 plus 4 and I divide by 2, what does that become out to be? It's 1 comma 4 and negative 2. 4 plus a negative 2 is also 2 divided by 2, which is 1. So that guy is at 1, 1. So they do not have the same diagonal midpoint, which means not a parallelogram. I'm just going to do this. He's not a parallelogram. He is, in fact, a trapezoid. Yes, you're right. What's true about a trapezoid? What does it have to be in order to be a trapezoid? One set of parallel sides, or 2 sides that are parallel, the opposite ones. Yep. Okay. He is not an isosceles trapezoid. We'll get to that. Okay. Isosceles trapezoid would mean the other 2 sides that are not parallel are the same length. We'll get to that. I mean, kind of. Whatever. Okay. Is that it? Oh, wait a second. We're going to skip example 4, and that's all. That's it. Okay. You have for homework, page 425. Page 425.
I'm clearing this.
This is 7. Is this 7-3?
You should do just 1 through 6.
1 through 10 and number 12. Okay, 1 through 10 and 12 and 14. Sorry. Yeah. 1 through 10, 12 and 14. Yeah. It's good for you. It builds character.
Good. It's not. I don't need to graph to do this.
I'm sorry.
Okay, I'm gonna draw like the word.
Actually, I don't really care. I don't really care.
And 14.
I don't really care. Okay, but you have to actually show me some work of how you know that, right? Don't just say yes or no. Like, I get that you can do some of that in your head, which is fine, but show me some stuff. Okay? 1 through 10, 12, 14. There you go. Work. Get done. No.